Welcome to Universe Orbit, your gateway to exploring the vast wonders of space, where the mysteries of the cosmos unfold through captivating videos. Don't forget to subscribe so you never miss a single voyage through the infinite universe. The solar system is a vast and intricate cosmic neighborhood that has fascinated humanity for millennia. It is our immediate celestial environment, a dynamic system of planets, moons, asteroids, comets, and countless particles, all bound together by the gravitational pull of our star, the Sun. As we begin our journey through this cosmic home, we are immediately struck by the remarkable diversity and complexity that exists within this seemingly orderly arrangement of celestial bodies. The Sun, at the heart of the solar system, is a massive sphere of glowing plasma that provides the energy and light necessary to sustain life on Earth. Its immense gravity dictates the motion of all objects orbiting it, from the largest gas giants to the tiniest meteoroids, creating a delicate balance that has endured for billions of years. The Sun itself is an average star in terms of size and brightness, yet its significance cannot be overstated. It is the source of heat and light that drives weather patterns, climate, and photosynthesis on Earth, and it serves as a reference point for understanding stars throughout the universe. Observing the Sun, we see a seething surface dotted with sunspots, enormous magnetic storms, and solar flares that release vast amounts of energy into space, sometimes impacting the planets in the form of auroras or disruptions in satellite communications. Moving outward from the Sun, the first planets we encounter are the inner or terrestrial planets: Mercury, Venus, Earth, and Mars. These worlds are composed primarily of rock and metal, characterized by solid surfaces and relatively small sizes compared to their gas giant neighbors. Mercury, the closest planet to the Sun, is a small, cratered world with extreme temperatures that swing dramatically between scorching heat and freezing cold. Its surface resembles that of our Moon, covered with impact craters that testify to a long history of cosmic bombardment. Venus, often called Earth's twin due to its similar size and composition, is shrouded in thick clouds of sulfuric acid, creating a runaway greenhouse effect that traps heat and makes its surface hotter than Mercury despite being farther from the Sun. Its dense atmosphere and extreme surface conditions make it one of the most inhospitable places in the solar system, yet it continues to intrigue scientists searching for clues about climate change and planetary evolution. Earth, our own home, is unique in the inner solar system for its abundance of liquid water, a stable atmosphere, and the presence of life. Its diverse landscapes, from oceans and mountains to deserts and polar ice caps, reflect the dynamic geological and atmospheric processes that have shaped it over billions of years. Earth's moon, orbiting faithfully, influences tides, stabilizes the planet's rotation, and provides a celestial companion that has inspired human curiosity and exploration for generations. Mars, the red planet, captivates the imagination with its rust-colored surface, massive volcanoes, and deep valleys. Evidence suggests that liquid water once flowed across its surface, raising the tantalizing possibility that life may have existed there in the distant past. Robotic missions and orbiters continue to study Mars, revealing its geological history, seasonal changes, and the potential for future human exploration. Beyond the terrestrial planets lies the asteroid belt, a region populated with rocky remnants from the early solar system. These asteroids vary in size from tiny pebbles to massive bodies hundreds of kilometers across, offering a glimpse into the primordial materials that coalesce to form the planets. Some asteroids follow predictable orbits, while others occasionally cross paths with Earth, reminding us of the dynamic and sometimes unpredictable nature of our cosmic neighborhood. Further out, the gas giants, Jupiter and Saturn, dominate the solar system with their immense sizes and powerful gravitational influence. Jupiter, the largest planet, is a swirling sphere of gas with bands of clouds, colossal storms, and a magnetic field so strong that it shapes the orbits of many smaller bodies. Its Great Red Spot, a storm larger than Earth, has raged for centuries, illustrating the extreme weather phenomena that occur on these massive worlds. Jupiter's moons, including the intriguing Europa, Ganymede, and Callisto, each present unique environments, some potentially harboring subsurface oceans beneath icy crusts that could support life. Saturn, famous for its spectacular rings, is another gas giant whose beauty and complexity continue to awe scientists and stargazers alike. Its rings are composed of ice, rock, and dust, forming intricate patterns and waves that shift over time. Saturn's numerous moons, such as Titan, with its dense nitrogen-rich atmosphere and hydrocarbon lakes, and Enceladus with its geysers of water ice, reveal the incredible variety of environments that exist even in the outer reaches of the solar system. Beyond Saturn, Uranus, and Neptune, the ice giants present a different type of world. Uranus, with its striking blue-green color due to methane in its atmosphere, rotates on its side, creating extreme seasonal variations over its 84-year orbit. Neptune, the farthest known planet, exhibits strong winds, dynamic storms, and a vivid blue hue. Both ice giants have multiple moons and ring systems, and their distant orbits make them challenging targets for exploration. Yet they hold key insights into the formation and evolution of planetary systems. Beyond the planets, the solar system extends into the Kuiper Belt and the scattered disk, regions populated with icy bodies, dwarf planets like Pluto, and countless comets. These distant realms represent the remnants of the early solar system, frozen in time, and they occasionally send comets hurtling toward the inner planets, providing spectacular displays and valuable scientific data. The solar system is not a static collection of celestial bodies. It is a dynamic, ever-changing system influenced by gravity, radiation, and the passage of time. Planetary orbits shift slowly, moons interact with their parent planets, and even the sun's energy output varies over cycles, affecting conditions throughout the system. Studying these interactions helps astronomers understand not only the solar system's past and present, but also the processes that govern planetary systems throughout the galaxy. The exploration of our cosmic neighborhood has evolved dramatically over the past century. From the first telescopic observations of distant planets to the launch of space probes and rovers, humanity has gradually uncovered the secrets of our solar system. Missions like Voyager, Cassini, New Horizons, and the Mars rovers have provided unprecedented insights into planetary atmospheres, magnetic fields, surface geology, and potential habitability. These discoveries continually challenge our understanding and inspire new questions about the nature of planetary formation, the potential for life elsewhere, and the future of human exploration. The solar system also provides a laboratory for understanding fundamental physical processes. The motion of planets and moons illustrates the laws of gravity and orbital mechanics, while the study of planetary atmospheres informs climate science and the potential consequences of human activity on Earth. Comets and asteroids reveal the composition of the early solar system, and the study of meteorites provides direct samples of material that formed billions of years ago. Each component, from the smallest dust particle to the largest gas giant, contributes to the intricate tapestry that is our cosmic home. The story of the solar system is not just one of celestial mechanics and planetary science. It is also a story of wonder and discovery. Observing the night sky, humans have long sought to understand their place in the universe, to interpret the movements of planets, and to imagine worlds beyond our own. Ancient civilizations mapped the stars, named the planets, and created myths and legends to explain the mysteries of the cosmos. Modern science has transformed these myths into knowledge. Yet the sense of awe and curiosity remains as strong as ever, driving continued exploration and inspiring generations to look upward and dream. As we journey through the solar system, we also come to appreciate the delicate balance that allows life to flourish on Earth. The position of the planets, the energy of the sun, and the protective influence of gas giants like Jupiter, which shield Earth from frequent catastrophic impacts, all contribute to the conditions that make our planet habitable. Understanding these relationships underscores the uniqueness of Earth while highlighting the interconnectedness of all celestial bodies within the system. Beyond its immediate scientific importance, the solar system invites philosophical reflection. It challenges us to consider the scale of the universe, the nature of time and space, and humanity's role in the cosmic arena. Each discovery, whether a new moon, a distant dwarf planet, or the detection of organic molecules on a comet, expands our awareness and compels us to reconsider our assumptions about life, existence, and the universe itself. In addition to its planets and moons, the solar system is filled with diverse phenomena that reveal its dynamic nature. Solar wind streams outward from the sun, shaping planetary magnetospheres and influencing space weather. Cosmic rays, charged particles originating from beyond the solar system, interact with planetary atmospheres, contributing to complex chemical reactions. The heliosphere, a vast bubble created by the sun's magnetic field and solar wind, marks the boundary between our solar system and interstellar space, offering a protective shield against high-energy cosmic radiation. The outer reaches of the solar system are home to enigmatic objects such as the Oort cloud, a hypothetical spherical shell of icy bodies that extends thousands of times farther than Neptune. These distant objects occasionally become long-period comets, traveling vast distances to visit the inner solar system and reminding us of the immense scale and interconnectedness of our cosmic neighborhood. As we continue to explore and study the solar system, new technologies and methods expand our capabilities. Space telescopes allow us to observe distant worlds and phenomena with unprecedented clarity, while robotic explorers traverse planetary surfaces and relay detailed data back to Earth. Advances in artificial intelligence, propulsion systems, and remote sensing enable increasingly sophisticated missions, bringing us closer to understanding the solar system in its entirety. Education and public engagement also play a crucial role in fostering appreciation and awareness of our cosmic home. Planetariums, observatories, documentaries, and interactive media allow people of all ages to experience the wonders of the solar system, inspiring curiosity, creativity, and a sense of stewardship for Earth. By sharing knowledge and discoveries, we cultivate a global perspective that emphasizes the shared nature of our place in the universe. The journey through the solar system is both scientific and deeply human. It is a journey of observation, exploration, imagination, and discovery. Each planet, moon, asteroid, and comet tells a story of cosmic history, of formation and change, of forces both violent and gentle shaping their existence. By studying these celestial bodies, we learn not only about the universe around us, but also about ourselves, our origins, our fragility, and our potential to explore, adapt, and thrive in the vast expanse of space. Looking ahead, the future of solar system exploration promises to be even more extraordinary. Ambitious missions aim to return samples from Mars and asteroids, explore the icy moons of the outer planets, and perhaps even establish human outposts beyond Earth. The potential for discovery is immense, from understanding the origins of water and life to uncovering the secrets of planetary formation and the boundaries of habitability. The solar system, in all its grandeur and complexity, serves as a constant reminder of the beauty, mystery, and boundless possibilities of the cosmos. It is a dynamic, interconnected system where each component plays a role, where forces of unimaginable scale and subtlety operate simultaneously, and where humanity continues to expand its understanding and reach. In contemplating our cosmic home, we gain a deeper appreciation for the fragility and wonder of life on Earth, the intricate patterns of celestial mechanics, and the profound questions that drive exploration, curiosity, and imagination. Our journey through the solar system is ongoing, a testament to human curiosity, ingenuity, and the timeless desire to understand the universe we inhabit. It is a journey that challenges our perceptions, broadens our horizons, and reminds us that while we are small in the cosmic scale, our capacity for discovery, understanding, and awe is limitless. As we move beyond the well-known planets, we encounter the smaller yet fascinating members of the solar system that reveal its history and complexity. Dwarf planets such as Pluto, Eris, Haumea, and Makemake inhabit the outer reaches, primarily within the Kuiper Belt, a vast region of icy objects beyond Neptune. Pluto, once considered the ninth planet, offers a vivid illustration of the diversity found even among small worlds. Its surface is a complex mosaic of nitrogen ice plains, towering mountains of water ice, and deep canyons, while its atmosphere, though thin, exhibits seasonal changes as it sublimates in sunlight. Pluto's largest moon, Charon, is locked in a gravitational dance with its parent, showing tidal interactions that provide insight into the dynamics of binary systems. The Kuiper Belt itself is a repository of ancient material from the early solar system. Studying these icy objects offers clues about the processes that govern planetary formation and the distribution of volatile compounds such as water, methane, and ammonia. Many of these bodies are remnants of a time when the solar system was chaotic, with planetary migration reshaping orbits and scattering smaller objects to distant reaches. Occasionally, gravitational perturbations send some of these bodies inward, turning them into comets whose bright tails light up the night sky. Comets are among the most spectacular phenomena in the solar system. As they approach the sun, solar radiation heats their surfaces, causing ices to sublimate and release gas and dust that form glowing comae and streaming tails. Observing comets allows scientists to study primordial material that has remained largely unchanged since the solar system's formation. The compositions of these icy travelers, rich in organic compounds and water, may even hold clues about how life's building blocks were delivered to Earth billions of years ago. Asteroids, primarily concentrated in the asteroid belt between Mars and Jupiter, present a contrasting population of rocky and metallic bodies. They vary dramatically in size, composition, and shape, ranging from irregular, jagged rocks to spherical objects hundreds of kilometers across. Some asteroids are remnants of protoplanets that never fully formed, while others may be fragments of larger bodies broken apart by collisions. Studying asteroids offers not only insights into planetary formation, but also practical benefits, as near-Earth asteroids could potentially be mined for resources or pose impact risks that require careful monitoring. The solar system's moons are equally diverse and fascinating. Earth's moon, with its familiar phases and surface features, serves as a natural laboratory for understanding planetary geology and the history of impacts. Mars' two small moons, Phobos and Deimos, are likely captured asteroids, offering a glimpse into the complex interactions between planets and smaller bodies. Jupiter's Galilean moons, Io, Europa, Ganymede, and Callisto, demonstrate an extraordinary variety of geologies and potential for habitability. Io is the most volcanically active body in the solar system, its surface constantly reshaped by intense tidal heating from Jupiter's gravitational pull. Europa, covered by a smooth ice crust, may hide a global subsurface ocean warmed by tidal forces, making it a prime candidate in the search for extraterrestrial life. Ganymede, the largest moon, possesses a magnetic field, a rare feature among moons, while Callisto shows a heavily cratered, ancient surface that records billions of years of impacts. Saturn's moons are equally compelling. Titan's dense atmosphere and methane lakes evoke images of an alien Earth, with seasonal weather patterns and potential chemistry that could support prebiotic processes. Enceladus, despite its small size, harbors a subsurface ocean and spectacular geysers that eject water vapor and ice into space, hinting at conditions suitable for microbial life. These moons, and many others, demonstrate that the solar system is not limited to planets in its capacity to harbor dynamic processes and potential habitability. Beyond the major planets and moons, the solar system contains vast fields of dust and ice known as the zodiacal cloud, formed from debris left by comets and asteroid collisions. This dust interacts with sunlight, creating phenomena such as zodiacal light, a faint glow visible near the horizon in dark skies. Though subtle, it is another reminder that the solar system is filled with matter both large and small, constantly interacting under the influence of gravity and radiation. The sun, our central star, remains the primary driver of these interactions. Its energy output governs planetary climates, drives the solar wind, and shapes the heliosphere, the protective bubble that shields the solar system from the high-energy cosmic rays that permeate interstellar space. Solar activity follows cycles, with sunspots, solar flares, and coronal mass ejections fluctuating over an approximately 11-year period. These phenomena not only influence space weather, but also affect satellite operations, communication systems, and even power grids on Earth. Observing the sun and its interactions with the solar system is essential for understanding both the conditions on Earth and the broader astrophysical processes that govern stellar systems. The exploration of the solar system has advanced dramatically with human ingenuity. Robotic missions have ventured to every planet, many moons, and several comets and asteroids, providing detailed observations that transform our understanding. The Voyager spacecraft, launched in the late 1970s, traveled beyond the outer planets and continues to send data from interstellar space, revealing the boundary of the heliosphere and the influence of the sun's magnetic field far beyond the planets. The Cassini mission revolutionized our knowledge of Saturn and its moons, revealing the complexity of Titan's atmosphere and the water ice plumes of Enceladus. New Horizons provided humanity's first close-up images of Pluto, exposing a surprisingly diverse and geologically active world. Mars rovers, from Sojourner to Perseverance, traverse the Martian surface, analyzing soil, rocks, and atmosphere to search for signs of past water and potential life. These missions exemplify the combination of engineering, science, and imagination required to explore worlds that are light years away from everyday human experience. Human spaceflight, though limited to Earth orbit and the Moon, has offered critical insights into living and working in space. The Apollo missions demonstrated the feasibility of landing on another world and returning safely, while the International Space Station provides a laboratory for studying long-duration space habitation, microgravity effects on the human body, and the development of technologies essential for future exploration of Mars and beyond. Plans for returning to the Moon under international initiatives and potential crewed missions to Mars mark the next chapter in human engagement with the solar system. Beyond exploration, the solar system serves as a source of inspiration and education. Observatories, planetariums, and digital media allow people around the world to witness solar eclipses, planetary transits, and meteor showers, fostering a sense of connection to the cosmos. Scientific research and discoveries are increasingly shared globally, enhancing understanding of planetary processes, potential hazards, and the origins of life. The narratives we construct around our solar system blend empirical knowledge with imagination, encouraging curiosity, creativity, and reflection about humanity's place in the universe. Looking at the solar system as a whole, we recognize patterns and connections that speak to the underlying principles of astrophysics. Planetary orbits, though influenced by past collisions and migrations, follow predictable paths governed by gravity. The distribution of rocky and gaseous bodies reflects temperature gradients during the formation of the solar system, while the presence of water, organic molecules, and magnetic fields demonstrates the interplay of physical and chemical processes that shape planetary environments. Even the smallest meteorites contribute to this story, preserving records of the early solar system and the materials from which planets and moons were built. The scale of the solar system is staggering, with distances measured in millions and billions of kilometers. Light, traveling at nearly 300,000 kilometers per second, takes over 8 minutes to reach Earth from the Sun and several hours to reach the outer planets. Communication with spacecraft at the edge of the solar system requires careful planning and patience, highlighting the immense distances that define our cosmic neighborhood. Yet despite this vastness, humanity continues to reach outward, propelled by curiosity, technology, and the innate desire to explore. The gravitational interplay between planets, moons, and smaller bodies shapes the architecture of the solar system, creating resonances and orbital patterns that influence stability and long-term evolution. Jupiter, the most massive planet, exerts a powerful gravitational influence that shepherds asteroids in the main belt and Trojan groups, while also protecting the inner planets from frequent catastrophic impacts by redirecting comets and smaller bodies. Saturn's complex ring-moon interactions illustrate how gravity can sculpt structures in space, forming gaps, waves, and braids in the rings caused by tiny moons or moonlets, whose gravitational pull subtly modifies the ring particle's motion. Uranus and Neptune, though less massive than Jupiter or Saturn, also create orbital resonances that affect distant Kuiper belt objects and scattered disk bodies, emphasizing the interconnectedness of the entire system. Tidal forces, another manifestation of gravity, operate on multiple scales throughout the solar system. They generate heat within moons such as Io, driving intense volcanic activity, and Europa, where the frictional heating of a subsurface ocean may create conditions favorable to life. Even Earth's tides, influenced by the moon and the sun, regulate ocean currents, influence climate, and have shaped the evolution of life over geological timescales. Observing these tidal phenomena across different worlds allows scientists to understand the complex balance between orbital mechanics, energy dissipation, and geological activity, highlighting the subtle yet profound influence of gravity beyond mere motion. The formation of the solar system itself was a dynamic, violent, and intricate process. Roughly 4.5 billion years ago, a massive cloud of gas and dust collapsed under gravity to form a rotating disk known as the solar nebula. At its center, the sun ignited as nuclear fusion began, while particles in the surrounding disk coalesced into planetesimals and eventually into planets and moons. Differentiation, the process by which dense materials sink to form cores, while lighter materials form mantles and crusts, must shape terrestrial planets. While the accumulation of venom created the gas and ice giants further from the sun. With collisions, migrations, and resonances during this early period set the stage for the solar system we observe today. And studying these processes provides a blueprint for understanding exoplanetary systems across the galaxy. Small bodies such as comets and asteroids preserve ancient material from this era, offering glimpses into the conditions of the early solar system. Meteorites that fall to Earth provide direct samples of these primordial materials, revealing isotopic compositions, mineral structures, and organic compounds that offer insight into chemical processes that may have contributed to the origin of life. Even tiny dust particles that drift through space carry signatures of the solar system's formation, helping scientists piece together a timeline of planetary accretion, differentiation, and chemical evolution. The solar system is also a dynamic environment shaped by energetic phenomena. Solar wind, a continuous stream of charged particles from the sun, interacts with planetary magnetic fields and atmospheres, generating auroras on Earth and other planets. Coronal mass ejections, massive bursts of plasma, and magnetic fields can have dramatic effects on planetary magnetospheres, inducing electrical currents, disrupting communications, and providing natural laboratories for studying plasma physics. Cosmic rays from distant supernovae and other energetic events in the galaxy constantly bombard the solar system, altering chemical compositions on planetary surfaces and contributing to complex reactions in atmospheres and icy bodies. These energetic interactions reveal a solar system that is far from static, constantly influenced by forces from both within and beyond its boundaries. Human exploration of the solar system, though in its infancy compared to robotic missions, represents a new chapter in our cosmic journey. The Artemis program aims to return astronauts to the moon, establishing sustainable outposts that could serve as stepping stones for Mars missions. Concepts for crewed missions to Mars involve years-long voyages, advanced life support systems, and technologies for in situ resource utilization, such as extracting water and producing fuel from Martian regolith. Beyond Mars, long-term visions include human presence on moons, such as Europa or Titan, orbital habitats near the Lagrange points, and perhaps even ventures into the outer reaches of the solar system. These ambitions, while technologically challenging, reflect humanity's innate desire to explore, expand, and understand our cosmic home. The philosophical implications of studying the solar system are profound. Observing the vast distances, extreme environments, and interconnected dynamics fosters humility and a deeper appreciation for the uniqueness of Earth. It prompts reflection on the fragility of life, the importance of planetary stewardship, and the need for international collaboration in space exploration. By understanding the solar system, we gain insight into fundamental processes that govern not only our celestial neighborhood, but also the universe at large, bridging the gap between empirical science and existential contemplation. In addition to exploration, the solar system serves as a laboratory for comparative planetology, a field that examines planets, moons, and smaller bodies in relation to one another. By comparing the atmospheres of Venus and Earth, scientists learn about greenhouse effects and climate evolution. By studying the ice-covered moons of Jupiter and Saturn, researchers gain clues about subsurface oceans and the potential for life beyond Earth. Observing volcanic activity on Io and cryovolcanism on Enceladus illuminates the diversity of geological processes driven by heat, gravity, and chemical reactions. This comparative approach allows scientists to develop broader theories about planetary formation, evolution, and habitability that can be applied to exoplanets orbiting distant stars. Education and public engagement remain central to the ongoing fascination with the solar system. Planetary science inspires not only researchers, but also artists, writers, and filmmakers, influencing culture and sparking imagination. Observing meteor showers, solar eclipses, and planetary transits connects everyday life with cosmic processes, reminding us that we inhabit a living, dynamic solar system. Interactive exhibits, virtual reality simulations, and citizen science projects allow people worldwide to participate in data collection, analysis, and discovery, fostering a global sense of connection to our shared cosmic home. The solar system, in its entirety, is a story of continuous change. Planetary atmospheres evolve under the influence of solar radiation, chemical reactions, and geological activity. Moons migrate slightly due to tidal interactions, while ring systems dissipate or reshape over time. Comets lose mass with each solar pass, asteroids collide and fragment, and dust migrates throughout the inner and outer regions. Even the sun, slowly converting hydrogen to helium in its core, is evolving, gradually increasing its luminosity over billions of years, with eventual consequences for the planets and the habitability of Earth. Understanding these dynamic processes provides context for our observations, emphasizing that the solar system is not a static snapshot, but a living, evolving system with a deep history and an ongoing story. Looking outward, the solar system serves as a template for understanding other planetary systems. Thousands of exoplanets have been discovered orbiting distant stars, displaying remarkable diversity in the tissue, composition, and orbital architecture. By studying our own system in detail, we gain the tools and frameworks necessary to interpret these distant worlds, to predict their potential for habitability, and to understand the physical laws governing planetary formation across the galaxy. The solar system thus functions as both a laboratory and a benchmark, grounding our understanding of the cosmos while inspiring exploration and discovery far beyond our immediate neighborhood. Our cosmic journey is far from complete. Future missions will probe the depths of icy moons, return samples from asteroids and Mars, and perhaps uncover evidence of life beyond Earth. Advancements in propulsion, artificial intelligence, and space habitats promise to extend human reach into the outer solar system. Even as telescopes peer deeper into the galaxy, revealing countless planetary systems, the solar system remains our closest and most accessible laboratory, a rich and diverse collection of worlds where the principles of physics, chemistry, and life itself can be studied in unparalleled detail. The story of the solar system is a story of connections between planets and moons, between small bodies and large, between energy and matter, between past, present, and future. It is a story that unites observation, theory, and imagination, blending scientific rigor with the awe-inspiring beauty of the cosmos. It is a story that invites everyone, whether a professional scientist or a curious observer, to partake in exploration, to marvel at celestial phenomena, and to reflect on the profound and intricate universe that surrounds us. The solar system reminds us that we are part of something immense and interconnected, a cosmic family of worlds bound together by gravity, shaped by energy, and enriched by history. Each planet, moon, asteroid, and comet contributes to a symphony of motion and transformation, offering endless opportunities for discovery and wonder. By studying, exploring, and contemplating this system, humanity gains insight not only into the mechanics of the universe, but also into the nature of curiosity, creativity, and our enduring desire to reach beyond the familiar and venture into the unknown. Beyond the planets, moons, and known small bodies lies the vast frontier of the outer solar system, a realm that continues to challenge our understanding and inspire exploration. The Oort cloud, a hypothesized spherical shell of icy objects surrounding the solar system at distances up to 100,000 astronomical units, represents the furthest reaches of our cosmic neighborhood. Though no spacecraft has yet traveled to this distant region, its existence is inferred from the origins of long-period comets that periodically visit the inner solar system. The Oort cloud serves as a reminder of the immense scale of our system, a repository of ancient material that has remained largely untouched since the solar system's formation, carrying secrets of the primordial cloud from which all planets and moons emerged. Beyond even the Oort cloud, the solar system blends imperceptibly into interstellar space, the vast expanse between stars filled with diffuse gaussian cosmic rays and magnetic fields. The boundary of the heliosphere marks the edge of the sun's influence, a protective bubble generated by the solar wind that shields the planets from high-energy radiation. Voyager 1 and Voyager 2, humanity's most distant emissaries, have already crossed into interstellar space, providing unprecedented insights into this transition region. These missions demonstrate that the solar system is not isolated but interacts with the broader galaxy, exchanging matter and energy, and that our understanding of its limits is still evolving. As we consider the future, human exploration promises to transform our relationship with the solar system. Ambitious plans envision crewed missions to Mars, sustainable lunar bases, and even the concept of space habitats positioned at stable orbital points. Technologies such as advanced propulsion systems, radiation shielding, life support systems, and in situ resource utilization will be critical to support long-duration missions. The potential to harness the resources of asteroids, moons, and even the solar wind may enable humanity to live and work in space, extending our presence far beyond Earth. Scientific objectives of these missions include searching for signs of past or present life, understanding planetary climates and geology, and preparing for potential planetary defense strategies against asteroid impacts. In parallel with human exploration, robotic missions will continue to probe the farthest reaches of the solar system. Future spacecraft may study the icy moons of Jupiter and Saturn in unprecedented detail, explore the dwarf planets of the Kuiper Belt, and investigate the origins of comets and other small bodies. These missions will provide critical data on planetary formation, chemical evolution, and the conditions necessary for life. The integration of artificial intelligence and autonomous systems will allow spacecraft to navigate, collect data, and make decisions in real time, increasing efficiency and expanding the frontiers of exploration. Beyond direct exploration, the solar system serves as a touchstone for understanding exoplanets and planetary systems throughout the galaxy. Observations of distant stars reveal an astonishing diversity of worlds, including gas giants in tight orbits, super-Earths larger than our planet, and planetary systems with multiple stars. By studying the architecture, dynamics, and chemistry of our solar system, scientists develop models that help explain these distant systems, providing context for the search for life and the conditions that make planets habitable. The principles learned at home allow us to interpret alien worlds, bridging the gap between the known and the unknown, and offering insight into the processes that govern planetary systems universally. The solar system is also a profound source of philosophical and existential reflection. Observing its vastness, complexity, and interconnectedness fosters a sense of humility and wonder. It reminds us of the fragility of Earth, the uniqueness of conditions that support life, and the importance of stewardship over our planet. The intricate dance of celestial bodies, the passage of billions of years, and the subtle interplay of physical forces invite contemplation about time, existence, and humanity's place in the cosmos. Studying the solar system thus nurtures not only scientific understanding, but also curiosity, creativity, and a deeper awareness of our relationship with the universe. In contemplating the solar system, one cannot ignore the aesthetic and emotional dimensions it evokes. The sight of planets rising and setting, the shimmering glow of distant comets, the grandeur of Saturn's rings, and the ethereal beauty of auroras all inspire wonder and creativity. Artists, writers, filmmakers, and educators draw on these celestial images to engage the imagination, to tell stories that blend science and narrative, and to communicate the splendor of the universe to audiences of all ages. By integrating art, science, and storytelling, The solar system becomes not just a subject of study, but a source of inspiration, a bridge connecting the empirical with the emotional, the observable with the imagined. Ultimately, the solar system is a narrative of continuity and change. It tells the story of formation from a primordial cloud, of evolution through collisions, migrations, and chemical transformations, and of ongoing processes that continue to shape planets, moons, and small bodies. Its story encompasses extremes, from the scorching surface of Mercury to the frozen expanse of the Kuiper Belt, from the volcanic fury of Io to the serene ice plains of Pluto. It encompasses forces visible and invisible, energy both gentle and violent, processes immediate and spanning billions of years. Through observation, exploration, and reflection, humanity becomes part of this story, gaining insight into both the cosmos and ourselves. The solar system, in all its complexity, diversity, and beauty, is more than a collection of celestial objects. It is a dynamic, living laboratory that invites exploration, challenges our understanding, and inspires awe. It is a system where every planet, moon, asteroid, comet, and dust particle plays a role, where energy and matter interact in intricate ways, and where the principles of physics, chemistry, and biology converge to create environments as varied as they are fascinating. By studying this cosmic home, we gain not only knowledge of the universe, but also perspective, imagination, and a sense of wonder that fuels the human spirit. In the end, our journey through the solar system is both scientific and profoundly human. It is a testament to curiosity, ingenuity, and the enduring desire to explore and understand. From the sun that sustains life to the distant icy bodies at the edge of the Oort cloud, every element contributes to a narrative of formation, evolution, and interconnectedness. By looking outward, we also look inward, reflecting on the fragility of Earth, the resilience of life, and the boundless possibilities of human discovery. The solar system is not merely a backdrop for human existence. It is an active participant in our story, shaping conditions, inspiring exploration, and revealing the laws that govern the cosmos. As we continue to explore, observe, and imagine, the solar system remains a source of endless wonder, a canvas of scientific discovery, and a reminder that humanity's quest to understand the universe is as limitless as space itself. In contemplating our cosmic neighborhood, we embrace a journey that stretches across space and time, linking the familiar landscapes of Earth with the distant alien worlds that orbit our sun. We are reminded that while the universe is vast, our solar system is a microcosm of complexity, beauty, and potential. A place where the principles of physics unfold on a scale both comprehensible and awe-inspiring. In every crater, storm, geyser, and orbit lies a story of formation, evolution, and the subtle interplay of forces that govern the cosmos. It is a story that continues to unfold, inviting future generations to participate, to discover, and to marvel. The solar system is, in every sense, our cosmic home, a place of wonder, mystery, and endless exploration. By studying it, we not only expand the boundaries of human knowledge, but also deepen our connection to the universe, inspiring curiosity, reflection, and a profound appreciation for the intricate and beautiful system in which we live. It reminds us that the pursuit of knowledge is unending, that the universe is vast and full of surprises, and that our place within it, though small, is filled with the potential for discovery, understanding, and wonder. Every orbit traced, every comet observed, every moon explored, adds to a tapestry of understanding that enriches both science and imagination, ensuring that the story of the solar system is a story that continues to captivate, educate, and inspire.